This will be for the con exercise, Evaluate Radical Expressions Challenge. So for this exercise, you want to remember, if you have x times y, that entire quantity to the power of a, that exponent a gets distributed to both terms. So that's going to be x to the power of a times y to the power of a. And of course, since it's equals, you can work this both ways. If you have two different terms to the same exponent, in this case a, you can multiply those two terms and raise that whole thing to the same exponent. So that's what we're going to do in this exercise for the most part. I'll add to these notes if necessary. All right, so we have the fourth root of 1/3 times the fourth root of 48. Notice that these are both the fourth root, okay? So if you recall, if you have a square root, let's say the square root of x, that's equivalent to x to the 1/2 power, okay? Which when it's square root, it's root 2. Here we have the fourth root. And we don't have x, but as an example, the fourth root of x is the same as x to the 1/4 power. All right, so we can convert each of these to the 1/4 power since it's fourth root. All right, so fourth root of 1/3 is going to be 1/3 to the power of 1/4. And 48, fourth root of 48 is the same as 48 to the 1/4. Now, as we said in the beginning, when the exponents match, you can combine these two terms. Okay, so this is going to be 1/3 times 48, and that whole thing is to the power of 1/4. I am allowed to multiply these because the exponents match. 1/3 times 48, or 48 divided by 3, is just 16. And that's still to the 1/4 power. All right, and we said 1/4 is the same as fourth root. So that's the fourth root of 16. And basically, it's asking what multiplied 4 times would give us 16. If we expand the 16, we know that 16 is the equivalent of 2 times 2 times 2 times 2. All right, and it's the fourth root. And since it's multiplied 4 times, the fourth root of all that is just 2. All right, just as with the square root, you would cancel 2 of these. When it's the fourth root, you cancel 4 of them. You bring it outside. I highly recommend you do this exercise by hand and try not to use the calculator. It works much better that way. Now, I really didn't need to do this step right here. These are both fourth root, so I could have just said 1/3 times 48 is the fourth root of 16, and then the fourth root of 16 is just 2. Okay, once again, notice the exponents match. 1/3 to the -2/5 times 96 to the -2/5. Since the exponents match, we can combine these two terms through multiplication and have that same exponent. So this is going to be 1/3 times 96. And that quantity, that product, is raised to the power of -2/5. All right, 1/3 times 96, or 96 divided by 3, is going to be 32. And again, that is to the power of -2/5. Now, since this exponent is negative, we can move this whole thing into the denominator and change the plus minus sign. You can pretend that this is divided by 1. Okay, and I'm going to move this whole thing into the denominator. All right, so that is going to be 1 divided by 32 to the power of 2/5. All right, and this is going to be the equivalent of 1 divided by, this is 32 squared. The numerator is the exponent and the denominator is the root. So it's going to be the 5th root of 32. And we can make that whole thing squared. Okay, I simply converted the denominator from exponential form to radical form. All right, and we know that 32 is the same as 2 to the 5th power. All right, if you want me to write it all out, I will write out the 5 2's, and it's the 5th root of 2 multiplied 5 times. That's the equivalent of 32, and that whole quantity is squared. All right, the 5th root of 2 multiplied 5 times. Since it's the 5th root, you can just cancel 5 of these 2's. And you're left with 2 squared. And 1 over 2 squared is the equivalent of 1/4. Remember, when you have a fractional exponent, the numerator is the exponent and the denominator is the root. Okay, so 32 is squared, and it's the 5th root of 32 squared. The 5th root of 32 squared. This 2 could be here or it could be here. It's the same thing. Okay, but the exponent, the numerator becomes the exponent and the denominator becomes the root, just like I wrote here. That's how I got the 1/4. All right, 1/4. Okay, notice once again here the exponents match. They are both 5/3. So we have a -7 times 1 over 56. Let me write I'm going to write times with a dot because I'm going to use parentheses for the exponent. All right, the exponents match, so -7 times 1 over 56, and that product is raised to the power of 5/3. Uh, 56 divided by -7 leaves us with -1 over 8. And that is to the power of 5/3. Okay, once again, the numerator is the exponent, the denominator is the root. So this is going to be -1/8. And that's the 3rd root of -1/8. And that whole thing is to the power of 5. The numerator is the exponent. The denominator is the root. All right, 3rd root of -1/8. What multiplied 3 times will give us -1/8? Well, let's see. If I did -1/2 times -1/2 times -1/2 and took the 3rd root of that, that would just be -1/2. Okay, and that entire quantity is raised to the 5th power. All right, so -1/8 is the same as -1/2 multiplied 3 times. And since it's the third root and it's multiplied 3 times, the third root of negative 1/2 multiplied 3 times is just negative 1/2. Okay, and that is to the power of 5. In the numerator, if you multiply negative 1 5 times, that's negative 1. If you multiply 2 5 times, that's 32. Final answer. All right, negative 1/32 right in the box. A negative sign in the front of the fraction or the negative sign in the numerator, that's the same thing. In the numerator or in the front, that's the same thing. All right, last one. Notice that the base numbers match right here. I'm just going to add this to the notes real quick. All right, let's say you have x to the power of a divided by x to the power of b. Now, these do not have to be variables, okay? These can just be matching numbers. But as long as these two variables or numbers match and you're dividing, you keep that base number, whatever it is, in this case, x, and you just subtract the exponents going down, a minus b. All right, so I'm going to use this property on this problem. Okay, so notice the 125 matches the 125. So the exponent, you just subtract going down. Negative 11 over 12 minus negative 1 over 4. All right, so it's negative 11 over 12 minus negative 1 over 4. All right, so watch your plus minus signs there. All right, I just subtracted the exponents. We keep the 125. 2 negatives in a row make it positive. Okay, and we need a common denominator. Here it's 12, here it's 4. How do we get from 4 to 12? Well, you do times 3. All right, 4 times 3 is 12, and 1 times 3 is 3. So 1/4 is the same as 3/12. So negative 1/12 plus 3/12. I'm sorry, negative 11/12 plus 3/12. All right, all I did was make a common denominator, and that's going to be 125. Negative 11 plus 3 is negative 8. And the denominator is 12. All right, reducing that fraction. Negative 8, it's negative. 8 divided by 4 is 2. 12 divided by 4 is 3. So recall, when the exponent is negative, you can shift this entire thing into the denominator. Okay, you can put it over 1 if you like, but it's really the same as 1 divided by 125 to the power of 2/3. All right, so we have the 1 in the denominator. The numerator is the exponent, the denominator is the root. So it's going to be the third root of 125 squared. All right, the third root of 125, and that quantity is squared. And what multiplied 3 times will give you 125? Well, 125 is the equivalent of 5 times 5 times 5, and that entire quantity is squared. All right, so we have the 1. The third root of 3 5s is just going to be a 5, and that's squared. And, of course, 1 over 5 squared is going to be 1 over 25. All right, the 5 is multiplied 3 times, so the third root of that is just 5. We still have the squared. That's 1 over 25. 1/25. All right, so try to do these by hand without using the calculator. Only use the calculator if you really need it for small calculations.